In this module, we learned about dimensional model development. The dimensional model is the foundation for everything that we build in our analysis services database. It's required to build our cubes as well as our dimensions. We started by learning how to build a data source. A data source consists of connection information, the server and database name, as well as impersonation information, which describes which security context is used to connect to the data source during processing. Then we learned about top-down versus bottom-up design. When we use a top-down design approach, we define our design inside of beds and then use wizards to automatically generate the tables. However, we'll need our own ETL process to load those tables with data. More often, we use the bottom-up approach, where we already have tables built in a data mart or data warehouse, and then use the structure of those tables to build our design inside of bits. We learned how to use the cube wizard using the top-down design approach. In the wizard, we identified the measures that we wanted to add to our cube and grouped them in measure groups. We defined the aggregation functions to be used with each measure, and then we defined the dimensions that we wanted to include in our cube. Then we used the dimension designer to get more specific about each of those dimensions. We identified the key columns, name columns where applicable, and added additional attributes that were useful for grouping or sorting or filtering within a dimension. And then, as the last step of our top-down design approach, we use the schema generation wizard. The wizard prompts us for database schema options. For example, do we want to enforce referential integrity? The wizard also prompts us for naming conventions. Conventions like whether or not we want to use separators between words in the names of our tables and columns, and what type of suffix we want to use for primary keys and foreign keys. Then we learned about the data source view. The data source view gets created by the schema generation wizard when we're using the top-down approach, but we can also use the bottom-up design approach to identify the tables and views that we want to have in our data source view available for cube and dimension design. We can enhance the data source view with named calculations or named queries when the structure of our data does not quite support our requirements in the cube and dimension design. If our underlying tables do not have primary keys defined, we'll need to add logical keys to uniquely identify each record in a dimension table. They're not required for fact tables, by the way. And we need to make sure that we have relationships properly defined between fact tables and dimension tables, and also between the different tables that are involved in a snowflake dimension. Having these relationships and keys defined correctly is important when we process analysis services and load data into our cubes and dimensions, because without the keys and relationships, we're likely to have problems with the data in our analysis services database. And here are some references for you to use to learn more. In particular, if you're new to star schema database design, refer to Designing the Star Schema Database. It's a good general reference for learning more about fact and dimension table design. The other links provide reference materials for the other concepts that we discussed in this particular module: designing data sources, working without an existing relational schema, in other words, the top-down design, and then working with data source views.